Today, we have with us Mr. Shino Babu, Managing Director, TIERA Private Limited. Prior to starting this company, he has worked as an assistant professor in VKC College of Engineering and Baselios College of Engineering and Technology. We are delighted to have him as our guest speaker today. Without further ado, I would like to hand over the session to Shino, sir. I welcome you, sir.
Thank you. Thank you very much. Could you see my screen?
Yes, sir.
Are you seeing the PPT?
Yes, sir. Yes, sir.
Yes. Okay. So thank you very much for the sweet introduction. I need not to say much more about that, and let me just enter into the topic. See if my voice is breaking, or if you have any interruption, please let me know. You can just speak in between that. It's not a problem, because online classes are very hectic, because we don't see the students in front of us, and we don't know what the response is from there. So if you feel any problem from my side, you can just interrupt. Okay, is my voice audible and everything is clear now?
Yes, sir, it's very clear.
Yeah, fine. Okay, so let me just enter into the topic. And the topic is a very crucial thing about a final year project. Normally, our S5 students as well as S7 or S8 students do have a fear in their mind about when they hear the term about project. And most of the students do think that it is something, a great, something, the thing that the university and the college insist on the student, and it's creating a great headache to the students how to deal with this thing. So today I will just, within 1 hour or 50 minutes, I'll just share my experience and also the way in which I am moving nowadays with dealing with project, because project is not a thing that is to be ended by, that will end up by in your curriculum. But beyond that, it is there wherever you go and do your job. The thing which is the job which has been assigned to you will be a project. So before that, I'd just like to take a few minutes to make you to understand that what projects means. Because this is, I think that because I used to speak with a lot of students in my daily life, and many students comes and speaks to me and tells to me that, sir, project, I don't know what to do. I don't know whether I will get the results and all. And students like from S5 onwards, they feel it very hard to tackle this problem. It's not a problem, but we have to, the students should be able to, the students should be made aware about what project is. And it is not culminating, or it is not to make you, it's not to create a headache for you guys, but there is something behind that which a student is supposed to know. And that is what I'm going to share for 5 minutes about what project is in your curriculum. See, normally, most of you have a good touch. I think that all of you students have a good touch with your seniors who have passed out and who are working in different MNCs or industries and like that. One of the major problems which both industrialists as well as teachers, academicians face is that, because since I know that I am addressing to students alone, and since I was a student, then I was a teacher, especially I worked in your college too. And now also I'm doing majority of the time I used to teach, and that is why I'm doing the same profession of teaching itself. So most of the thing that we say about students is that most of the students, our students, especially electrical or any branch, whether you are, they are less motivated. We teachers are supposed to push all the students and make them to do this, do that, write this or do that, read that. Like this, a big complaint used to come from the side of teachers. And we always complain about the students, that the students have no interest in learning. Like all these things happen. And the students will be capable of passing their papers and all, and they will get a good result, and then they will go to a job. And once when you go for a job also, I also have the same, since now I'm being an industrialist, I also observe students, and I also have jotted out a lot of problems. Why when I absorb a fresher in my, if you ask me a question, sir, will you absorb a fresher? Then I have to wait for 5 minutes. I have to think about that, because directly I won't absorb a fresher directly. It's not speaking about a negative way, but when you be in a company, that is what I'm just planning to say. By this, I think when I say that answer and when I say the meaning of that, that will create you an understanding that the project seems to, it's going to benefit you alone, only the students, nothing else. So industrials have a problem, is that students taken from this college, or the students whom we absorb as freshers, what happens is they feel very hard for learning things. That is one of the biggest problem which most of the company staffs or company heads who HR managers who faces that and who complain, is that students, when I absorb a fresher, the problem which they face is they are not in a state to learn by themselves. So this is a problem. So I'm going to address both this question and an answer, and see that all the end result comes from students. I'm just pointing, and since I know that all the audience are students, so it is not, I'm not just complaining you, but two people, one from academic sides and one from the industry sides, or from the job oriented HR side. Both of them is pointing out certain points that they are expecting students to be in such a manner, such that the teachers say that students are less motivated, they're not much interested in engineering, and like that some complaints. Also the industrialists, or the people who offer jobs for engineers, they say is that people are not able to learn by themselves. So what happens is that now the market as well as the industry where we work or where we are going to be placed are expecting something. The thing that they're expecting is that there is a type of learning which all the companies are expecting, that is known as a self-based learning. Normally, sometimes you may have heard about this term, but normally the type of learning which we implement in our colleges or in our institutions is a direct one-to-one learning. The teacher is going to speak about a lot of knowledge, and they are going to impart this knowledge to a student and say that write this 10 times, and then you by heart that, then you mug up it, then you write it on your paper, thereby you will score 9.8 GPA. This is a type of learning which it's just going on, which is carried over for a couple of years, and that is being done now also. But that alone will never help us when you be there in an MNC or in an industry. Now, what is expected there is that you should always have a mind of learning by yourself. This is very difficult, because most of the students tell that, say, we need people to come near to us, sit near us, and tell us. Normally in Malayalam, we'll say that padi. Normally, all the students are very hard to hear about these words. So this is not what the industry expects. Something else. So that is what I'm going to address that, and that is what the university as well as your college or institution is going to is sticking on to certain subjects and certain so they have added certain things in your curriculum for making students to have a habit of self-learning. That is the thing. Is it clear?
Yes, sir.
Okay, so I could just hear one person saying that yes. Okay, so here what happens is that self-learning is very important nowadays. And here in my slide on the right-hand side, you will see this is this report which I have read from an HR manager of Mercedes-Benz, and he is just sharing his opinion about absorbing young engineers and the problem which he faces. And he said that, see, knowledge is the thing that we want, and we build on knowledge, and we build on engineering principles. But the actual part of learning, there he says that here, if you see that here in the screen, there is 10% of the knowledge which we learn, that we will only grab only 10% of our knowledge from colleges. Remaining 90% is from a self-based learning technique. That means you will be given a problem and you have to sit, you have to think about that, you have to have a very good cooperation with your team. You will share your knowledge, they will share their knowledge, and together they will work together to solve real-time problems. So this, as part of making students to have a self-based learning, your university as well as your college institutions will implement students to do they will try to make students to do a self-based learning or a project-based learning. That is a one type of method that is known as project-based learning, because that is why this part is included in your S5, sorry, S6, S7 and S8. In S5, I think in S6 you have a paper known as design engineering or design project, or in S7 you have a seminar and a project preliminary, and in the S8 you have a project. If you could read the course objective of all these three subjects, the objective is very clear that the paper has been insisted on making students to learn by themselves, for by observing things and to understand, make things, to get things or understand things and try to do it. So project is implemented in your curriculum so as to make students to think in a particular way that you have to learn by yourself. And that is why project is based. And that is the definition that I've mentioned, that project has been used as a learning method. That is known as a project-based learning. It is very effective. Most of the foreign universities are implementing this thing. Also, the KTU is also implementing this. That is why in first year onwards, they have given much more rewards and credits for students who are doing mini projects and something like that. And that is only to attract students to learn by themselves, apart from depending upon teachers or apart from learning from classroom alone. They are making students to have a habit of learning by yourself, and that only will help you when you go in a job. When you go be there in a job, you can't survive unless you have this type of character. If you don't have this character, it is very hard for you to survive. So project has been implemented. It's a learning method. Understand that it's not a fear. It's not a technique for creating headache, or it's not a technique that has been developed by the university or the college to screw up students, but it is a type of learning method, making students to learn and understand things. And this project-based learning is a very good paper or a technique where you can learn a lot of things apart from your classroom learning. So that is why this has been implemented. This project is implemented. Now, is it clear? Is this part clear?
Sir.
Yes, sir.
Yes, okay. So the second part is that the second part also. So I think I have very clearly I've defined the meaning of project and why it has been implemented to you guys. The second part, then the second question comes, sir. If it is a project, then from where should I start? Where should I start? I have a lot of students who used to call me and just ask me, sir, do you have any project topics? So I could understand the motto behind that, and I could understand the mindset of the students who called me, because students very commonly used to think about project when the department insists that next Friday on 2 o'clock we have a project presentation. So you guys are supposed to present for 10 minutes or 15 minutes. At the time only students starts to think about project. Or at the time of S5 or S7, only these times, it's only the time when the deadline is made. At that time, only students will start to think about projects. So it commonly creates a fear and all, but that should be eradicated. And you need to have fear and something. But I will just help you how to guide, how to have this opinion. So the first problem is where to start, or from where will I see, from where will I find a problem? That is a problem. What are the ideas, or what are the ideas that can be taken as a project? Here in the screen, could you see my slide?
Oh, sir.
Yes. So you will see, you will see an aeroplane. Please don't ask me that, sir, here there is no electrical. I'm basically an electrical engineer. I've studied MTech in electrical machines, but I work now in a system. I also have the same notion, because whenever I get a project, whenever I read a project, I will look for some electrical parameters, whether there is voltage or speed or RPM or efficiency or something, an induction motor or a transformer or something else. If it's not there, then I will come to a conclusion that this paper is not good because it's not related to electrical. But in my experience now I will never say that, because there is no project particularly based to electrical. When you deal with a project, you need to know mechanical engineering, you need to know civil engineering, you need to know structural mechanics, you need to know electronics and all. So when you try to find for a problem, because this is the question what most of the students do have, sir, from where should I start? From where should I get a project topic? Should I Google it, or should I ask someone, or should I go and give money to some institutions which does project for us? This is not an answer. The answer for that is just look around your surroundings. Just look around the surroundings. There are a lot of problems which you face. Know that engineers are there to not to create problems, but to find solutions for problems. But problems are there in in our surroundings. We have a lot of problems. Our society is facing a lot of problems, and we are going to implement. We are going to just find out solutions for these problems by the theory and by the principles which we have learned in engineering. This is a diagram, this is a figure which I've just made because this is one of an interesting area which I have and which I learn about. Airplane industry is one of the biggest industry, and most of the students have a great desire to work in, especially in Boeing or in something, Airbus or something like that. But there are certain, so the first question comes, what is the role for an electrical engineer or an engineer there in Airbus or in Boeing? What are they going to do? What are an engineer? What is the role of an engineer? Because we have predefined systems over there, and how will I be fit for that job is a question. So here you will see on the left and right hand side, I have just mentioned the two applications. One on the right extreme left hand side, you will see a screen, and on the screen some green dots and lines are there. Could you see that?
Yes, sir.
Yes, sir. Yes.
Yeah, this is one of the most commonly used technology, which is known as an unmanned system or an autopilot system. I hope you have all heard about these things, autopilot system, because normally most of the aircrafts have an autopilot mode where the pilot is not supposed to steer the plane. It is one predefined path will be fixed, and then the plane will move in the same path. That is an autopilot system, and this part is all part of engineering. There are a lot of engineering principles behind that. Control systems or mechanical systems are there. Many things are incorporated in that, and thereby they make the whole system. The second part on that, on the right hand side, is you have sometimes people who play video games and all. You have seen this thing because this is an anti-locking system, a locking system for used in MiG-2 airplanes. There is a locking system because once you see your enemy, it is very hard for you to find the target. So this is a technical system, a locking system which has been developed, which has been used by an engineering technology principle, where once you grab the photo of your enemy fighter plane, and then you just press a button, means lock. At that time, automatically a missile will move from your fighter plane, and it will strike the target very clearly. So all these things makes us, we will know that a lot of things that I learn or we learn that is being used in real-time data. But the question comes, sir, what is the problem here? What is the problem here? Is there any problem here? There is no problem. Autopilot system is very much used nowadays, and also this locking system for fighter planes are being used. But what are the problems? There are a lot of problems in airplane industry. I'm just telling you this as an example. A lot of problems in airplane industry. Most of the problem with airplane industry happens is that in autopilot system, it has been navigated by using a lot of sensors. Here in this slide, you will see I just made two pictures where a lot of all these are sensors, different sensors placed on the airplane structure. Now the data from all these sensors is grabbed, and then microcontroller or a processor will be there, and thereby it will steer that the engine speed should be this much. Since the wind speed is in this much kilometer per hour, the engine speed or the thrust or the pressure will be or this much. The engine speed should be made at this speed. All this calculation is done by the inputs fed from the from the sensors. So there is a problem here. The problem there is because all aeroplanes fly in high altitudes. So sometimes when we go at higher altitude, sometimes the climate will not be same as that which we feel now here in the ground. So sometimes the sensors will get damaged, and once if the sensor is giving you wrong data, what happens is that this autopilot, once the flight is moving in an autopilot mode, then it will just stop the engine, and then it will fall down. That is, a lot of accidents has been taken place like this in the previous years. And these are the problems. I'm just telling you one problem, a single problem, which is very hard for us to solve. But for making you to think. One area which I am just sticking on and was telling that aeroplanes are normally used as a transport media, and most of the people are using it. The usage is very much high, but there are a lot of problems there. The second problem, is it very clear? Is this clear?
Yes, sir.
Yes, sir. Yes.
The second problem I could also
Yes,
say,
sir.
you see that two engines are there. Normally, bird attack is very much common when aeroplanes at the time when it takes off, or when it takes off at the time. Bird attacks is very common. So what happens is that, like, when birds attack the engine blades, sometimes what happens is that the blades get damaged. Once if the blades gets damaged at that time, then what happens is that then the aeroplane will be unstable and it will fall down. Its operation will be automatically stopped, and then it will fall down. Like a lot of accidents has been taken place in 2018 or 17, I think. So there's a similar accident took place. I think Malaysian Airways was the plane where it was taking off at the time. A bird attack came, and then its engine got crashed. But somehow around 359 people was there on board. But the pilot managed to land it at the moment. Once he realized that the engine got damaged, he was able to make it down, land the airplane in a safe manner. So these are the real-time problems which we have, and we have to find some solutions for this. Is this clear?
Yes, sir.
Yeah, don't worry. The examples might be difficult for you sometimes, because your question will never be answered. Sir, എവിടുന്നാണ് ഈ പ്രോബ്ലം കണ്ടുപിടിക്കുന്നത്, എവിടുന്നാണ് ഈ പ്രശ്നം കണ്ടുപിടിക്കുന്നത്? I just explained to you about a real-time example. Now I will also come down with some recent or some problems which we face. I will just tell you a simple example. A simple example. Now, the need of an hour is because we know this pandemic, corona or COVID-19 virus, and wherever we go, a lot of inspections are there. Whenever we enter a government office, there will be a person there who makes us to write your details, your name, your mobile number. He will take your temperature, and then he will record that in a book. It's a very tedious project, tedious process. So the employees or the institutes or the government institutes or the bank officials has to employ a person there to monitor all these things. And because it's a compulsory, and if you violate from that, then the government will take actions against the institute. I'm just telling you a simple problem. So what happens is that making a person sit there in front of your office and making him to ask all the people to come here, write your name, write your mobile number, making him to check the temperature and all, is a very tedious thing. So we can just find this a problem. Could you understand this?
Yes, sir.
Yeah, of course. So there is a question now. See, is this a problem? Yes, there is a problem. Now, what kind of solutions can you guys give? You can create a solution for that. An unmanned system. No need for a person to stand in front of your institute or your office. It will be an unmanned system, just like an ATM, something like that. And all the people are supposed to come there and line up there, and they have to somehow enter the details or something like that. Thereby, the door will be opened for the person. This is a very good. This is a problem which we are supposed. It's a need of the hour nowadays. And if you could find a solution for this problem, then that is a great achievement by you guys. And also another part of the thing which I just want to add to it is, see, while doing some projects related to what the industry does, that will fetch you a job. I am telling my personal experience. I'm working in this since I do provide solutions for industries. Some of the students used to come near to us for doing projects. And what some of the students, I will make them to do the work which I am doing for industry. So what happens is that once they study the system, and they will be part along with me in doing that work. And once the work is being done, what happens is that the same industry will absorb the students, because industry always wants to, they don't want to spend much money in training. So what MNCs and all companies which they look is that if I am doing something in, for example, have you heard about a term known as image processing?
Yes, sir, we have.
So I'm doing a project. I'm doing a work related to image processing. And I have what I'm going to do is that I'm just making it. I'm just finding I'm just doing and taking an image of a river, and I'm just predicting the speed or the speed of the speed at which the water flows in that river. It's a project which I'm going to do. It's an ongoing work which I'm doing. So what happens is that there are certain industries. It's done for an industry. An industry wants a solution for that, and I'm doing that in an automatic system, which means an unmanned system, where he can predict the level of water as well as the force, the speed at which the water comes, and thereby an alert can be given to the officials that somehow, because saying, okay, ഇത് കേട്ടിട്ടുണ്ട് ഉരുൾപൊട്ടലൊക്കെ കേട്ടിട്ടുണ്ടല്ലോ കേട്ടിട്ടുണ്ടോ?
Hello, sir.
So land slipping or landsliding like that. So it's a technique, it's a problem which an industry came, and I'm going to do that. I'm working on that project. So what happens is that I have some students also working with me, and they are also giving me input, and I'm making them to do along with me, and they are providing a solution. So what happens is that they are doing some real-time work, which that company or that industry wants to do. So once when the project is completed, what happens is that when these guys go and give their resume to these guys to the industry, they will see that we are working in an area, for example, very particular to in image processing, and these students have done some project related to related to image processing. Thereby what happens is that the industry will grab them rather than a fresher who is coming near to them. Okay, is it clear?
Yes, sir.
So that is what the relevance of your importance of your project. That is a theme which has been shared in this evening. What is by choosing your project also fetch you a job, because once you understand what industry does, and if you are in a part of a system where you work with that real-time problem, there you will learn a lot of things, and when you give your resumes to the same institute or to the company, they will directly absorb you. I have an example with me, because I was doing work with Mercedes-Benz. It was not, I don't have any project with the Mercedes-Benz, but they were doing a crash test, because you have heard about, because whenever a new model car is being launched, they will do a crash test. So I did do a small part of that. I created a setup, and then I was doing a crash test of a vehicle which I have, and then I took a lot of data from that, and then I did a prediction method of crash test. And what happens is that some students came near to me to do project, and I also included these guys with that. And once they have completed their project, they went to this company, Mercedes-Benz, and they gave their resume to this company. But what happened is that all that guys were being absorbed, and they are now working in Mercedes-Benz. The reason why they are being absorbed is not because of being studying in College of Engineering, Trivandrum. They were just studying from, these guys were first normal average students from self-financing colleges in Kerala. They were average students, not brilliant students or extraordinary students, just average students, but they had a mind of learning things. And they were when they were doing their project, they were part of a real-time work. And what the reason why the company grabbed them was that the company was doing also the same thing. They're doing testing, and they want engineers who have a basic knowledge about what that does. So this is the gap which industry has now, because they are finding it very hard for finding students who is having that knowledge or experience in the field in which they work. So this is the point of choosing project also has an importance. That is why your university or the college says that go outside and do project. Go outside and do project doesn't mean that you give 10,000 rupees to a project based company and they will do everything for this, because that has been diluted now. The reason behind that, why university as well as colleges insist students to do projects outside, is that because there is a lot of limitations in your college, in your I'm not speaking about MBCET alone. In every college, in any institution, there are limitations. Real-time problems cannot be solved in institutions. Sometimes there are certain companies where you have to seek help from external companies, where they will make you a part of the project which they do. So once when you be with them, that will boost your career, or that will make you open a lot of opportunities in your life. Now, I hope the project topic, how choosing a project and where to get a project or where to find a problem, I hope it is very clear for you. Now, once you sort out a problem, then the way of solving this is also another problem faced by students. From where to start, once you get the problem in your hand, how to do this project or how to find a solution for this problem. This is a next hurdle which all the students have. I also had the same hurdle. I also had the same problem when I was a student, when I did my BTech as well as my MTech. But after that, I came to know that there is one particular way of solving. There is a particular way in engineering, the scientific method of solving engineering problems. And this is the flow chart. If some of you, if you want to write it, you can just write it. I've just explained all these terms. Here, if you go in this particular manner, you will give. I'm not assuring you that you will get results, but you will learn new things in your life. In your project also, you will learn. Yes, yes.
Shino sir, can you click that hide that I can't see the screen?
Oh, sorry. Fine. It's clear.
Yes. There.
Okay. So this is the method in which I am also implementing when I get a real-time problem, or when a customer comes near me and tells to me that I want a solution, I have a problem, find a solution to me. Then this is the method which I implement nowadays in my day. So my experience I'm going to share, when I do the same thing, one thing I can assure is that I learn new thing in my life. The first method is that define the problem, find the problem. What is your problem? That should be very clear. Your objective. What am I going to do? What is the problem, and how will I find a solution? So once the problem, I will explain all these things. Don't worry. Just for the name's sake, I'm just telling this, just reading out these words. First, define the problem. The second one is do background research. Know that is there any solutions now? Is there any solutions found in the present time? Is somehow any scientist or engineer or any students or faculty, if has someone addressed this problem? That is the second part. Do a background research, because this is normally you all guys have heard about literature review. Your teachers, especially I also used to make students to do literature review. Students comes and say, sir, why should I do literature review? It is all wasting time. Because there is an importance of that. Why literature review is insisted to be done is that because you should know that this is the present solution. Some people in some part of the world have addressed this problem, and they found some solutions. They came out with solutions, and what happened is that they came out with certain solutions, and then they had some difficulties. So we will also be addressing that. That is the importance of literature review, and that is which is said as background research. The third part is specify your requirements. What is the output you are expecting from this problem? What are the solutions, or not the solutions? What are the output which you are expecting? I need this much values. That I will explain. Don't worry. When I say it, I know that it is not much clear to you, but I will explain all these points with a real-time example. The fourth thing is that you have to share your ideas, the problem, the various solution, the present literature review. What are the status? How many people have came out with a solution for this? What is the present scenario? What is the status of it? Then what type of solutions are you planning to do? And that is a fourth part, brainstorming or evaluate. This is what is being done by your presentation, your interim presentation, your first review, or second review, or third review. When you present your PPT, what is being done is that you are going to share your thoughts, your solutions, and your teachers and the people who sit in front of you will say that, okay, this solution will be okay, or this solution cannot be carried over because there is a lot of drawback. So this is a fourth part, is brainstorming or evaluation. Then you develop for a prototype. You will try to develop a miniature part or a prototype of that. You will test for solutions. And you see that whether it meets your requirements. If not, we will redesign. All the steps which I am saying, we will develop prototype, but the remaining, this part will never be over. This is the part, because when you go for a last moment project, these things will never be there. Only we will develop a prototype and we will be satisfied with what we get. But especially how a problem, an engineering problem is being solved is that once the prototype is developed, then you undergo testing and you see whether it meets your requirement. If it doesn't meet your requirement, then you have to sit back, or you have to think about, there is some mistake in my design. You have to find out where the mistake is. And that all these things will help you. Don't think that you are alone going to find a solution for that. Sometimes you will be able to find, or otherwise, while presentation, while your review meetings and all, your teachers will also help you to solve, to redesign the system, because experience also counts a lot of things. It matters a lot of things in this area. And that is why your college as well as university gives much importance in review. Okay, is this clear?
Yes, sir.
Yes.
Yes.
Now, once the solution, when the prototype works according to the requirements which you have developed, then the thing is that you have to communicate the results. Communicating the results means you are going to publish, you are going to write a paper, and you are saying that this is a real-time problem which we faced, and this is going to create a lot of havoc to the society, and there are a lot of solutions which came out in the previous years, but we have developed a solution and we have tested the system, and it seems that the solution, the problem has been eradicated, and we have such and such drawbacks. This is how the whole problem is being solved. And this is the only manner in which all the industry, whichever industries are there in this world, they are all following the same pattern. And whoever follows the same pattern, they will learn things and they will come out with a solution. This is the thing. Okay, now I'll just explain you all the things. I know that there's only 15 minutes more. I'll just explain you with a real-time example, because just saying something blah, blah, blah will never help you. I'll just tell you a real-time example. I'm just going to identifying a problem. Pardon me, because I know that students from civil is there, mechanical engineering is there, computer science students is there. I will also address you, don't worry. I'm just telling you a real-time problem. One of the problem is that normally you have heard about this, or you have read in newspapers that commonly a distribution transformer, the figure here sees your distribution transformer. There are some areas where the distribution transformers gets burned out. It burns out. It gets burned out. But there is nothing, no indication. There is nothing like that. Within an instant of time, what happens is that it gets burst off or it gets burned off. So this is a problem which our electricity board all over in our country faces, because there is no monitoring system for distribution transformer. So here, I'm just telling you, I'm just saying, it's an example. I'm just telling you that I have a problem here. I'm going to develop a solution for this problem. The problem is that I need to monitor the parameters to avoid burnouts. I need to just monitor the parameters of the transformer, and just make an indication system, or give it an indication system to the concerned people, such once if any parameters violates, thereby avoiding this burnout of transformer. Is the problem clear?
Yes, sir.
So the first step, I'm just following this pattern. I'm just following the same pattern, the same steps. The first step is that I'm going to define the problem, my problem objective. The problem is that I need to develop a health monitoring system for the transformer. Now the question, what is the relevance of this problem? The problem is that because why does this burnout happens? Because once when the transformer is overloaded, or sometimes if the oil gets derated, or something like that, what happens is that normally the distribution transformer, the transformer gets burned off. So it has, in order to avoid that, I need to avoid this problem. And that is the reason I said that what the relevance of the problem. Now, which sector is having the problem? Normally, electricity board or industries, as well as common people who consumes electricity has the problem, because if a distribution transformer gets burned off, then we know that power cut or load shedding, a power cut will be there in that area. And these guys will never be able to do their day-to-day activities. So this is a sector who is being affected if a transformer gets burned off. Now, what is the importance of solving the problem? Why do you want the problem to be solved? This is also a question. ചുമ്മാ ഒരു പ്രോബ്ലം കണ്ടതിന് ശേഷം ഞാനൊരു സൊല്യൂഷൻ കൊടുക്കുന്നില്ല. Is there any, do you want a solution for that problem? Is that problem, or is that area, or that question is to be answered? That we have to find the relevance of that problem, or the importance of the problem. And I'm going to say that I also find out a solution that yes, if this problem is solved, electricity board can increase the revenue, and there will be no disruption in power, or power failure can be avoided. And this is the process or the problem objective. Is this clear?
Yes, sir.
Yes, sir.
Yes. Now the second part is background research. I hope you remember this flow chart. The second one is the background research. Now I've just did some literature survey, and I found that there are certain journals or papers, IEEE or IJCS, MC, or something like that, and there some other people, some people in the nook and corner of the world have addressed this problem. They also have found this problem, and they came out with different solutions. Some have used Zigbee, some have used TSM technology, some have used wireless health system or something like that to solve this. I have read all this things, and I know what happens inside that. I'm not going to explain you all these things, but these things I just read, and I have in my mind that there are few people in this who have addressed this problem, and they have used various solutions. The third part of that is I'm going to specify what my requirement should be. If I find a solution to this problem, what are the outputs which I am going to, or what are the features which I am going to offer to the end user or to the customer? For example, if it is an electricity board, what if I'm going to try implement some solutions or implement some techniques which I have learned, and then these are the features which I'm going to give to my customers. Okay, so I'm just telling I have to have these much features. I should have some system which will be able to measure the voltage or current or power or temperature of the device or the transformer. Then once the data is being taken, I have to do some calculation for seeing that whether it has crossed the safety limit of the device. And if there is any if any parameters have violated the safety limits, then I have to use some system to give an alert to the user. So this is my requirement. Now with that requirement, I'm going to find out what are the various solutions. What are the solutions which I can implement, or which all solutions can I incorporate for solving this problem? Here in the slide, here on the extreme left-hand side, you will see the requirements which I have mentioned here in the same slide. Here, to measure voltage, current, and temperature, parameters for measuring the temperature or voltage or parameters, there are normally sensors. I will use any sensors, no problem. The second requirement is to obtain data and monitor the system. So obtain data is very simple. I just want some systems, some device which can take the data and convert that to a meaningful information. And then I have to monitor the system monitor this data in a remote system. And there are various options. For me, I can use Bluetooth, I can use Wi-Fi, I can use Zigbee, or any other options. If you have, you can use that. And there are certain comments which I have mentioned about the drawbacks of the system. And the third one is that I should make a system to alert the user for if there is any malfunction or something like that, or if any parameters have exceeded the safety limits of the device. Then I have to use some parameters, some techniques for giving an information or alert information to the student, to the customer. So there I am just telling that either I can use GSM, and automatic message will be sent to the electricity board or some of the customers, or I can use various normal technique known as an IoT, which is one of the technique which has been very much common now. So these are the various solutions which I have come across. That all these requirements, there are various solutions. I'm going to choose. I will tell you how I'm going to choose these solutions. Now, with these requirements, I'm going to draw. The second part is I've specified my requirements, and with my specified requirements, I have gone with a solution. I've jotted down what are the various solutions, or what are the solutions which I can implement. Now what I'm going to do is that I'm going to do the fifth part is to develop a prototype. And that is what I'm going to explain now. Now, before developing a prototype, the first part in developing a prototype, there are different parts. The first part is to develop a block diagram for it. System. I'm just drawing 3 blocks and just writing the requirements. Whatever requirements I've mentioned here, that I've made here. First block is a device for detecting various parts or parameters of transformer. The second block is some device or decision-making device should be there for taking this data, convert that to a meaningful information. And the third parameter, the third block is to just give some alert system to the customer once if the safety limit is being exceeded or not. Now, is this clear?
Yes, sir.
Yes, sir.
Yeah. So developing a prototype is selection of components. This is one of the other hurdle which students face. They will come out with block diagram because once the problem is there, I don't know the reason behind that, but every student coming out with a problem, first they will draw the block diagram. I don't know how it happens, but every students, every batch of students will have a block diagram. But after that, they find it very hard how to select components. Because selection of components is also a very difficult thing, and this can be only done by engineers. And there you have to know a bit of logic. Logic should be there in your mind, as well as your engineering principles which you have learned. You have to use these two principles for selecting components. Now, I know, as I've mentioned, the problem is to do a health monitoring of a transformer. So first of all, I need to specify the device or the requirements which I have. Shall I spare 10 more minutes more? I think the time has been exceeded.
Yes, sir, you can.
Okay, thank you. So what happens is that the components, before choosing the components, first of all, I have to mention the device which I'm going to use. And here it says that the parameter, I'm going to use a three-phase transformer. A three-phase transformer which is having a primary side voltage of 440 and a secondary side voltage of 220 volts. Its current is 5 ampere. It's a tri-type transformer which I'm going to use. Now, here in this transformer, I have to measure the voltage, current, and temperature. Now, for measuring the voltage, there are various sensors that is available in the market. I've just mentioned two names. One is a Hall effect sensor, and then is have you heard about PTs and all, potential transformer?
Yes, sir. For
Yes.
transformer.
So,
That transformer which measures voltage.
There is no transformer which measures. Yeah, of course, that is what which we learned. The transformer which measures voltage, that is potential transformer. But potential transformers, current transformers and all, have you heard?
Yes, sir.
Yes. Okay. So potential transformers or Hall effect sensors can be used for measuring voltage. Current also there is Hall effect sensors which can be directly used for measuring current, and the temperature can be measured by using thermocouples or RTDs, which is available readily in the market. So first of all, what I've done is that I have defined my system. This is the thing, this is the device which I have, and I need to measure the parameters of this device, and that is what I mentioned. I am using a three-phase transformer. Okay, now the first part which I want to measure a voltage. So I'm just using a Hall effect sensor. This is available in the market. Here certain specification is mentioned, because once you choose a sensor, you need to understand what is the input it measures, or what is the input that is to be fed to that sensor, and what is the output that you get. And that is what I have mentioned here on the extreme right hand side. This is the part where students find it very hard, and they don't give much more interest, or they don't give much attention to this area, because I have seen students directly going to some websites and just type current sensor, and what they see in the first two lines, they will just click it and just buy it. And once they will grab all the things, or they will buy all these things, and when at the time of connecting it between the system, then they find it hard, because where to connect, because one transformer or sensor has 4 pins, but your transformer has only 3 windings or 4 windings. Where should I connect? This is a big question which normal some of the students would have. I don't say that every student won't be having this doubt, but some students will have. So while choosing a sensor, you need to know what is that input that is being fed to this device, and what is the type of output that it gives. And that is what I've mentioned here. Here, the sensor which I'm using here, the input voltage which I can give to it is 500 volt AC, and the output voltage that I get is 5 volt. It's analog in nature. I just had to add something more here. Keep in mind that all the signals which we have, which we come across in our day-to-day life, there are basically two types of signals. I think you have studied in your signal processing or in some electronics paper. It's digital and analog. Have you heard about that?
Yes, sir.
Yeah. So here the sensor it says that the input that is being fed to it, the voltage, maximum voltage that I can give is 500 volt AC, and the output which I get is 5 volt. Pardon, this is not AC. AC means what I mentioned is analog in nature, and that is the output that I get. Here, this parameter has an importance, because why I've mentioned the output here is that because here what I'm going to do is that I give some input to my sensor, and I'm going to take the output from the sensor, and this output is going to be fed to some system. I don't know to what I'm going to connect. I will explain you about that. But that system should be able to handle this 5 volt value. If that system is not able to handle 5 volt, then what happens is that the system to which you are connected, it gets burned off. For example, I'll tell you a simple example. I think in there is a board known as Arduino Nano. I think it's the input voltage which we can feed. If there is a mistake, please, man, I don't remember the board name. For example, I'm just telling for a namesake, I'm telling. In Nano, the input which you can feed is only 3.3 volt. Okay, not in Nano, I'm sorry, this one, Node MCU. Yeah, Node MCU, the input voltage which you can feed to the pins is only 3.3 volt. But if I have Node MCU in my hand, don't worry about if any students are hearing it for the first time, don't worry. I'll just understand what I'm just telling, that's all. So if I am a Node MCU and I take this sensor and I connect this sensor value, the output of the sensor to Node MCU, what happens is that your Node MCU gets burned off because it is not compatible for acquiring 5 volt analog value. Is this clear?
Yes, sir.
Yes. So while you choose a sensor, these parameters you should mention. What is the input that the sensor needs, and what is the output that it gives? What is the magnitude of that value, and whether it is analog or digital in nature. The second one is the current. Current also I'm using a Hall effect sensor. This is a model known as ACS 712, which is a commonly used current sensor. And here it says that the current value is 10 ampere. Why I have chosen 10 ampere is that here in the specification of the transformer, I've told you that the maximum current is 5 ampere. So somewhat I'm using a sensor value which is more than 5 ampere. The things that is available in the market is 10 ampere. So this is a 10 ampere. 10 ampere means this IC can measure 10 ampere. The second part is what is the output? The output is when I give 10 ampere to this device, it will give you 5 volt, and the output is analog in nature. Is this clear?
Yes, sir. Clear.
Yes. The third part, temperature measurement. For temperature measurement, I am using a thermocouple. A thermocouple is a device which helps you to measure temperature. And also there are certain specifications. What is the temperature range which it can measure? This is the data sheet. From the data sheet, I have understood that this thermocouple is capable of measuring minus 30 degrees Celsius to plus 350 degrees Celsius temperature. And the output which it gives is voltage. It's a voltage. It is analog in nature, and the output ranges from minus 6.5 volt to 55 millivolt. Okay, is that clear?
Yes, sir.
Yeah. So my parameters, I have found these are the parameters which I had. I need to measure the voltage, current, temperature. That was my first requirement, and I came out with solutions. I have came out with 3 sensors which can be used to measure all the 3 parameters. I have understood that I have understood the output of each sensors. Now what I want to do is that, okay, this is also another component which I'm using ESP8266 module here for by using IoT. In a remote area, I'm not going to use Wi-Fi or Bluetooth or Zigbee and all. I'm using a normal technique known as an ESP8266 IC, a board, earthen board, for communicating the parameters and just to see the data in HTML. And that is what. And here also keep in mind that the voltage, that way of communication, your device which you're going to use, And that device is going to communicate with this ESP8266. The way of communication is in a serial manner. There are two types of communication, serial communication and parallel communication. I won't explain all these things because you have learned this in your theory and all. But the next point which you want to keep in mind is that the inputs which you are going to give towards this ESP8266 from your device, the magnitude of that input should be 3.3 volt. You are not supposed to give more than 3.3 volt. If you give more than 3.3 volt, then this device gets damaged. So this is the parameters which you have to keep in mind while choosing a sensor. So by this, all my component selection is, it's not over. Now I have my 3 devices in my hand, all these 3 devices in my input side for measuring the voltage, current, and temperature. Then what happens is that all these parameters will be directly fed to the ESP8266 IoT module. And thereby what happens is that this will be, all the parameters can be observed there in my HTML or my web page. Now for this, what happens is that, there are certain things which is required. The thing what is required is that once I have to have a device which works on a certain logic, which I'm going to implement. I will tell you what the logic is, and it will monitor and see that whether the parameters are exceeding the safety limit or not. So for that, a processor, and that is the second part, the decision-making device. In the block diagram, I've explained about this part. I've explained you about this part, but this part has, why do we require, because most of the students have a question, sir, why do you want a microcontroller in my project? I have heard some students, most of the students used to, they are reluctant of asking questions because they feel that you sir endu thonum allengil teacher endu thonum ennu chodikum. But now I know that because I also face the same problem when I was doing my project. So most of the students have a problem. Sir, why should I use a microcontroller? Is it required? Is it necessary for using a microcontroller in my project? How will I decide that? How will I decide to choose which microcontroller should I select? And all these things depends upon, see, in your project, if you want some system, if you want to implement or make the system to work in a particular logic, then you want a processing system. And that is what, or a processing system or a decision-making system. Here, a decision-making system means it is going to work according to a logic in which the user is going to say. The user is going to say that once these parameters comes, you have to check whether it has exceeded the safety limit or not. If it has exceeded the safety limit, some alert system should be given to the user. Also, whether if it is between the below the safety limit or above the safety limit, all the data is to be given to ESP8266 module such that all the parameters we will be able to view all the parameters in a remote area. So here you require a decision-making device. And there are 2 types of decision-making device. I think you have studied all these things. There is a microprocessor as well as a microcontroller. In normally common, wherever the processing is less or more, if you don't want much processing, then you use a microcontroller. There are different types of microcontroller that is available. Please keep in mind that the board which I have shown here is not a microcontroller. Arduino is not a microcontroller. It's a company that develops that board. The microcontroller they are used is Atmega. There are 3 or 4 types of microcontroller. One is 8051. I think you have studied about that in your curriculum. The second one is PIC, PIC. The third one is ARM, and there is one more thing I forget about the name. These are the 3 types of 3 or 4 types of microcontrollers are there available in the market. 8051, PIC is there, ARM is there, and there is one more. If I remember, I'll tell you these things. Now here I've just shown you a microcontroller. This is a commonly used development board, which students used to use. But there will be a question, sir, how did you select this board? Is it by the, what was the reason of selecting Arduino Uno alone? Why can't we use Nano, or why can't we use Dew, or why can't we use Raspberry Pi? Why can't we use Intel Galileo? How did you choose this board? Now the reason for choosing, there are certain parameters that you have to keep in your mind while choosing your microcontroller. The important parameter is just you have to identify what type of, how much sensors or how much output device you want to connect. Here I have just told you, here I've shown you the total number of sensors or device which I'm going to implement or connect it to my decision-making device is 4. The first one is your voltage sensor. The second one is your current sensor. The third one is your temperature sensor or thermocouple. The fourth one is your ESP8266 module. And here also I've mentioned you what type of communication or what type of signal does these all devices transmit to the decision-making device. Here you see that the voltage measurement IC or sensor is giving you some voltage which is 5 volt and that is analog in nature. The second one is a current measurement sensor which gives you 5 volt and that is also analog in nature. The temperature measurement thermocouple that also measures temperature and gives voltage which is analog in nature. And here that is an ESP8266 module which is going to communicate with your decision-making device, and that is done in a serial way of communication, that is by using TX or RX pin. So the microcontroller which I am going to use should have, basically it should have 3 analog inputs. The 3 analog inputs are voltage, current and temperature. And it should have a provision for connecting a device which can transmit or communicate certain parameters in a serial manner by using transmission or receiving pins. Is that clear?
Clear,
Yes,
sir.
sir.
Yeah, okay. So here in Arduino, I'm just randomly have chosen a board. Here in Arduino Uno, on the extreme left-hand side, I think you could see that here it is written at A0, A1, A2, A3, A4, and A5. So there are 6 analog pins. Here also it meets my my requirement. I should have minimum 3 analog pins, but here it is 5, so no problem. I can connect all my voltage sensor, current sensors, and temperature sensor directly to my Arduino Uno. And keep in mind that in an Arduino Uno, the maximum analog voltage which you can give is 5 volt. The maximum analog voltage that you can give, that is also there in the data sheet. I think I missed here. That is there in the data sheet. And if you see the value of all the sensors, 3 sensors there, all the 3 sensors gives you voltages, and that voltages lies within 5 volt. Then the fourth sensor which I'm going to connect is an ESP8266, and that communicates through a serial manner, or that communicates through in a serial port. So that serial port, the requirement I want is I should have 1 transmission pin and 1 receiving pin. And you will see on the extreme right-hand side of this board, there you will see serial port TXD, serial port RXD. Could you see that?
Yes, sir.
Yes. So the reason why I'm choosing this board is that because I can directly interface my analog inputs, as well as I can directly interface my serial communication device to this Arduino Uno. So that is how you choose your microcontroller. There are various other factors too. I'm just explaining the surface knowledge. This is the basic requirement. You have to see whether the sensor which you're going to connect comes under the limits, comes under the voltage limits or not. Here, analog voltage, the maximum analog voltage which I can give is 5 volt. So all the voltage sensors which I use works in 5 volt, and directly I can connect it there. And also my ESP8266 works in a serial communication mode, and that can be connected to my TX and RX pin. Okay. Now this is the wholeheartedly, I'm just combining all the things, my 3 sensors on my left-hand side for measuring the parameters of the transformer, and the ESP8266 module, which I have used here for giving the parameters, to cloud. I'm using 8266, and I've mentioned all the input and output. All I have mentioned here on the side. Now what I'm going to do is I'm just going to see whether this sensor is compatible with my Uno or not. Now here I'm seeing that this sensor works from 5 volt. I can directly feed 5 volt to DC. It's not a problem. Either you have 5 volt DC in your Arduino development board, or you can use a separate DC source. And the output which it gives is 5 volt analog. So no problem. I can directly connect my analog pin. I can directly connect my sensor to my analog pin, because Arduino analog pins can read a maximum analog input voltage of 5 volts. So no problem here. The second part also, current sensor, there is also no problem. It also gives 5 volt analog that can be directly connected to my analog pins. The third one is your thermocouple. The thermocouple has a problem there. If you don't see any problem here, there is a problem there. The problem is that there is you can directly connect it to your analog pins because the output voltage here is in voltage. It is varying in nature. That is why it is mentioned as analog. But the thing is that, see, the value is very small. The thermocouple gives you a maximum voltage. Here it is written as minus 6.5 millivolt to 55 millivolt. I have mentioned in the previous slide that, see, for minus 30 degrees Celsius, the voltage shown is minus 6.5. And for 350 degrees Celsius, the voltage shown is 55 millivolt. So that is a very small value. And there is a question there, will my microcontroller will be able to read this small value? That is a question. So there is also a question there. So here, for reading that, you need to know about a device known as an analog to digital converter. Have you heard about ADC?
Yes, sir.
Yeah, see, pardon me, I'm just exceeding the time. I will just conclude this by 2 slides, because if I'm not explaining these things, then it is a waste. You are spending 60 minutes or 15 minutes. It's a waste. I don't want to waste your time. When you spend 10 minutes or 15 minutes, you should gain things as well as I should also gain knowledge. So that is why I'm just telling that. I hope that these things will help you while you do your projects and all. So here, this parameter has a great importance, because this value, your microcontroller, I have a doubt whether my microcontroller will read that or not. But sometimes you may ask me a question, sir, microcontroller either read that I will tell you an answer, because in your electronics or in your digital circuits, you have studied about TTL and CMOS voltages. Have you heard about that?
What, sir?
TTL and CMOS.
Yes, sir. Yes, sir.
Transistor. CMOS എന്ന് കേട്ടിട്ടില്ലേ? TTL വോൾട്ടേജ്, ട്രാൻസിസ്റ്റർ ലോജിക്, CMOS ലോജിക് എന്ന് കേട്ടിട്ടുണ്ടോ? കേട്ടിട്ടുണ്ട്. TTL എന്ന് കേട്ടിട്ടുണ്ട്, CMOS എന്ന് കേട്ടിട്ടുണ്ട്. ഇത് രണ്ടിന്റെയും പ്രത്യേകത, ഇത് രണ്ടും തരുന്ന ഔട്ട്പുട്ട് വോൾട്ടേജ് വേറെയാണ്. TTL ആണെങ്കിൽ, if any circuits or IC, if you say that the logic is TTL logic, it means that it works in the lowest state is 0 and the highest state is 5 volt. Is that clear?
Yes, sir.
Yes. So what happens is that 0 to 5 volt it can read, and here in a digital system, you know that there is only 2 states, either on or off. And also you have studied there in your textbook that if the voltage is more than 3.5 to 5, then the microcontroller will come to know that the state is high. If the voltage is between 0 and 2, then the value is 0, then the state is low state. And any value between 2 and 3.5, that is known as an intermediate state. Have you heard about that?
No, sir. No, sir.
No, sir. Okay. Because because once you give an input to your microcontroller, how does a microcontroller know that whether an input is there in my input pins? For example, if I give some input to my digital pins, for example, എന്തെങ്കിലും ഒരു സെൻസർ ഞാൻ എൻ്റെ ഡിജിറ്റൽ പിന്നിലേക്ക് കണക്ട് ചെയ്തു. So how will a microcontroller know that there is some input is there in that pin or not? How will a microcontroller know that? And that decision is being done by checking the voltage that pin. For example, I am assigning 13. I'm saying that microcontroller, one sensor I am connected to pin number 13, please value the value of that pin. So what it does is that it will check the value of that pin. If that value lies between 3.5 and 5, the microcontroller will know that some input has been received in that pin. If the value is between 0 and 2, then the microcontroller will understand that there is no input to that pin. Is this clear?
Yes, sir.
Yes. Okay. So what happens is that this value, value, minus 6.5 millivolt to 55 millivolt, will the device be able to read that, is my question. And for that, what is the parameter? How will you know that whether the device will read that or not? Depends upon the ADC which is being used, the analog to digital converter which is being used. And in Arduino Uno board, what happens is that you have a 10-bit ADC. You have a 10-bit ADC, and the minimum voltage which it can read, ചിലപ്പോൾ ഇച്ചിരി കട്ടിയായിരിക്കാം. കട്ടിയാണെങ്കിലും കുഴപ്പമില്ല, നിങ്ങളത് മനസ്സിൽ വെച്ചാൽ ഞാൻ ഈ പറയുന്ന കാര്യങ്ങൾ ജസ്റ്റ് ഒന്ന് കേട്ടാൽ മാത്രം, ഇങ്ങനെ ഒരു സംഭവം ഉണ്ടെന്ന് മാത്രം അറിഞ്ഞാൽ മതി. So here in a 10-bit, you have studied all these things in 10-bit successive approximation, no, R2R type of approximation. These things and all you have studied in your measurements, electronic measurements or electronic instrumentation paper. You have studied that. So this microcontroller, Atmega 328, is a microcontroller used in Arduino Uno. It has a 10-bit ADC. The 10-bit ADC means 10-bit ADC. From 10-bit ADC, I can find the minimum voltage which the device can detect. And that is found, that term that is mentioned here is resolution. Resolution means the minimum voltage which the device, the ADC, can detect. And that can be found by the formula Vref divided by 2 raised to n minus 1. Don't worry, Vref is the maximum voltage which I give to that pin. Here my maximum voltage is 5. 2 raised to n is 10 raised to 24. 10 raised to 24 minus 1 is 1023. And the minimum voltage which my 10-bit ADC can read is 4.8 millivolt. That is the thing. So when 1 degree Celsius, when the thermocouple, when there is a change in 1 degree, means when there is a change in 1 degree Celsius, the minimum voltage which the ADC can measure or can detect is 4.8 millivolt. But in my system, when I use a system, when I use this thermocouple, a K-type thermocouple, which I'm going to use, here it says that it can measure up to minus value to 350 degrees Celsius. I don't want minus value because I know that my device will never work below 0. It will never work in below 0. So it is always the temperature will be greater than 0. And the normal range will be somewhere around 90 degrees Celsius or 80 degrees Celsius. So it will be giving some values between 0 and 55 millivolt. And will that be able, can I read that value? Means it is very hard. By using a 10-bit ADC, this is very hard. I'm not going to spend much time for that. And for measuring 1 degree Celsius, it takes a lot of time for explaining these things. So I'm not going to explain much more. Here in my system, I want to measure the temperature which is having a resolution or which is having a resolution of 1 degree Celsius. And for measuring 1 degree Celsius, change in 1 degree Celsius, the output voltage required to be detected is 150 microvolt, and that is not possible by this ADC, which is inbuilt in Arduino Uno. I cannot use this ADC, which has been used here. So I require an external ADC and an analog to digital converter to be placed. I know, I'm sorry, it is hard. But even though you are S6 students, you can directly, this will help you in your while you design in your projects and all. This will help you because I just want to impart this thought in your mind, because there is something concept like this which you have to keep in mind, because normally blindly whatever we see in Google or in Google Images, whatever the circuit which you do, you will copy it and explain that. But many students find it hard to tell an answer why I'm using this components or why I'm using an external ADC. The students find it very hard to find an answer for that. I just want to eradicate that thought. Whenever you get a block diagram in your hand, you should think, why is this block being implemented here? Why is this device being used here? Is there any reason for that? That you have to find. And that is why I am explaining these things in this manner. So for connecting my thermocouple to my Arduino, I need to use an external ADC, and this external ADC, it should have a bit size of greater than 10 bits. Then only I will be able to measure the accurate voltage or accurate temperature which is being given, which has been taken from the windings of the transformer. The other thing which is this clear? Somewhat, I think so.
Yes, sir.
Yes. The fourth part is your ESP8266. Here also we have the problem. I have explained that problem. ESP8266 is going to be connected to your TX and RX pin. And here in Arduino Uno, in the specification, it says that all the voltages, all the maximum voltage which the digital pin as well as the analog pins, which it can give is 5 volt. 5 volts. So if I connect my ESP8266 directly to your TX and RX pin, the magnitude of this pins will be 5 volt. But this 5 volt, this device ESP8266 is not compatible with 5 volt. There it says that I am supposed to give only 3.3 volt. So here this voltage is 5 volt. Here the voltage which is required by ESP8266 is 3.3 volt. If you directly connect it, this device will be burned off. So for avoiding that, what you have to do is that you have to use some device for reducing 5 volt to 3.3 volt. Therefore, I will be using, in my circuit, I will be using a voltage divider circuit. Voltage, this is the block diagram. This is how I bring out with my, first I have shown you a block diagram, or this can be named as a modified block diagram or your circuit diagram. I have my voltage sensor. My voltage sensor will be directly connected to my analog pin. Sorry, I have not mentioned here analog. Current sensor will be directly connected to my analog pin. Temperature sensor can be connected directly, but it will never give me accurate results. For that, I will be using an external ADC. And then my TX and RX pins cannot be connected directly to my IoT module. Thereby, I will be using a voltage divider circuit for reducing my 5 volt to 3.3 volt. An external power supply, 12 volt, will be given for turning on the microcontroller board. So this is the final circuit diagram or the final block diagram. My requirements, I have shown you my requirements. Then I have chosen the various solutions for that. Then I've chosen all the sensors. I know what the output it gives. And with the output, the sensor, what type of output the sensor gives. With that, I have chosen my controller. And then I've seen that whether it can be directly connected or not by the output parameters. If not, I have added external circuits, external devices or external circuits. I have implemented certain circuits for making the device work in a proper manner. Then the fourth one, the last part is your algorithm. How does the device work? How should the decision-making device, how you want the device to be worked? So this is a common algorithm. I need not to explain you about these things because students feel very hard. Algorithm can be developed by students. It's not a problem. But students feel hard for selection of components and how to connect things and all. And what are the points that they have to, key points which they have to keep in mind while selecting components and interconnecting devices. This is clear. Then once if the algorithm is being implemented, you use any IDEs or all IDE like STM or means Arduino IDE or C++ or Python or whatever IDE you can use, and you run the system and see whether it meets your requirements. See whether it meets your requirements. If it meets the requirements, you can develop. If it meets the requirement, then you can go. If it doesn't meet the requirement, you just see whether design changes should be implemented. If it is not, then you write your paper and get published, and thereby you share your results with the real time to the real world, such that other people will be easy. It will be making people easier for finding solutions for problems. Okay. Thank you. Thank you very much. Sorry for taking my extra time also.
Oh, no problem, sir.
Thank you, sir.
Thank you.
Thank you, sir, for that amazing session. And thanks to you, we have a lot to take away today. The link for the feedback form will be sent to your mail. So please kindly fill it. So if you have any doubt or questions, you can ask Shino sir now.
It's no doubt.
Okay. I hope there are no questions. Now I call Devika to deliver the vote of thanks.
Good evening, all. On behalf of IET MBCET and myself, I would like to thank our guest speaker, Mr. Shino Babu, who, despite of his busy schedule, has found time to grace this occasion and share with us this valuable information. Now, I would like to thank Jo Miss for her support, guidance, and encouragement to our efforts. And I would also like to thank Suji Miss, our staff coordinator, for her guidance. And next, I would like to thank all the IET members for their constant support. Last but not the least, I would like to thank each one of you for being the part of the event and making it a success. Thank you.
Thank you. Thank you very much.